Hi everyone, welcome back to the channel. So we are solving the CBSE 2026 Maths Standard Paper Set 1 Section C, and here is question number 26 for you all. The question is, prove that root 5 is an irrational number. So this is a standard question from the chapter Real Numbers, right? And every year we expect these type of problems, right? So how do we solve these questions? Using the method of contradiction, okay? Method of contradiction means we will assume the opposite. Okay, they are asking us to prove that root 5 is irrational. So we will assume to the contrary that it is a rational number. Okay, so we will assume let root 5 is a rational number. If root 5 is a rational number, we know that every rational number can be represented in the form of A by B, okay, or P by Q, whatever you want to write, you can write here. I'm writing here P by Q, okay. Now the condition is where P and Q are co-prime integers. Now what is the meaning of this co-prime integers? Co-prime number means the highest common factor of P and Q is 1. So any two integers will be called co-prime if their highest common factor is 1. So yes, that is the condition. P and Q are co-prime integers and Q cannot be equals to 0. That is the condition. Now what is the next step here? We can multiply here and then square, or you can square it here. So let's cross multiply, then we can square it. So cross multiplying, we are going to get root 5 into Q is equals to P. Now squaring both sides, what we are going to get is, you square both sides here. So that will be 5Q square is equals to P square. This is what we have so far. Okay. Now we know a theorem. Okay, and we are going to proceed with the proof with that theorem. Let's see here. I can write it like this: Q square is equals to P square by 5. 5 is a prime number, okay, and P is any positive integer. Okay, so I know the theorem that says that if this divides 5 divides P square, then by that theorem it will divide the positive integer P also. Okay, what is that theorem? If P is any prime number and P divides A square, that is any positive integer, then it will divide A also. So here this is P, that is the prime number, and this is A here. So if 5 divides, this is a short form, this is how we write it. That meaning is 5 is a factor of P square, therefore 5 will be also a factor of P. That means if 5 divides P square, therefore it will divide P also. That is the meaning. Okay, so let me write the conclusion here. P is divisible by 5. Okay, if it is divisible, then there will be some constant, right? So as constant as the quotient, right? So I can write here, let me take it as R because we have taken PQ. So let me take it as R and let this be equation number 1. Now if that is the case, that 5 is a factor of P and it is giving the quotient R, therefore I can further write it as 5R. Okay, plus remainder is 0 because it's a factor. All right. Now what I can do is I can put the value of P in this equation here. So what I'm going to get here is, or in this equation. So what I'm going to get here is 5Q square. Let me write here. 5Q square is equals to P square. And from equation number 1, we know that P is equals to 5R. Okay. So let's put the value here. 5Q square, therefore, is equals to 5R whole square, right? and this is 5q square is equals to 25r square, right? Let's simplify this. That will be giving me q square is equals to 5 times of r square. That can be further rewritten as q square divided by 5 is equals to r square. So what is this again? From this equation we can come to the conclusion that if 5 divides q square, that means if 5 is a factor of q square, therefore 5 will also be a factor of q, that means 5 will also divide q. Okay, so from these two conclusions, q by 5, again we are going to get some quotient. Let me call it as s this time. Okay, so let's suppose this is, or let's take something else because it's looking like 5. Okay, so let me take t here. Doesn't matter, any variable you can take. So we just want to know that here this is divisible by 5. 5 is a factor, so we are getting some quotient, and this is equation number 2. From equation number 1 here and equation number 2, what we are able to observe this, that this 5 is a factor which is dividing p also, and it is dividing q also, right? It is dividing p also and it is dividing q also. But in the beginning, what we have assumed that p and q are co-prime numbers. They should not have any common factor other than 1. That means, that proves that, let me write here, 5 divides both p and q. Therefore, 5 is a factor of p and q. That is the meaning. Okay, factor of p and q. And hence, finally, we can say that p and q are not co-prime numbers. That's it, we are done. They are not co-prime numbers. And hence, at the last, we will write that, therefore, our assumption is wrong. Our assumption is wrong, and root 5 is an irrational number. Okay, so that is the standard proof for these type of questions. I hope it is clear to you. Okay, so I'll just give you a quick summary that how do we write this question. We do not have to memorize anything here. See, first of all, we'll write by the method of contradiction. We will assume that this is a rational number. Rational number can be written in the form of p by q. So we have to write this line. This is a very important line because this is important for the proof at the last. So p and q are co-prime numbers. Q cannot be equals to 0. Then we have to square it, and we have to prove that 5 is a factor of p square. So by the theorem, I can write that 5 is also a factor of p. Okay. Then because it is divisible, it will have some quotient. So you can take it any variable here. Then you will get this equation. This equation you have to put in this equation again. So the same thing we are going to get for q also. Okay. At last we have proved that yes, it divides both p and q, and hence p and q are not co-prime. So that is the flow of this question. Okay. This is the flow that you have to follow in order to solve this question. I hope this is clear. Moving on to the next question. Yes, again, this is a very good question. Find the coordinates of the point of trisection of the line segment joining the points A and B. So, let me show you the diagram here. This is point A having the coordinates -1, 4. This is point B, which is having this is point P, okay, having the coordinates xp, yp, just to distinguish that this is the x coordinate of P and this is the y coordinate of P. You can also take it as x1, y1, doesn't matter. Okay. Now let's see here. Q is having the coordinates x cube, y cube, and finally B, which is having the coordinates -3, -2. Now, why we have taken the points like this? Because they are saying that points of trisection. Trisection means this part, and this part. We are dividing this complete line segment AB into 3 equal parts. 3 equal parts means AP is equals to PQ is equals to QB. That is the meaning of trisection. Now we have to find the coordinates here of P and Q. So we have two options. First, we will find the, we'll take the ratio. If you consider AP is to PB, that is, this PB is what? 1 plus 1, that is 2. So it is 1 is to 2, and AP is 1 parts out of total 3 parts, right? And from this we will find the coordinates of point P. And secondly, you have an option that you can find the coordinates of Q by taking the midpoint, because see, this is what? The PB is one line segment, 1 is to 1, that means Q is the midpoint of PB. So you can directly find the coordinates from here, or else what you can do is you can apply the same thing at this point, and then you can take 2 parts and 1 part. Okay, so 2 is to 1 you can take, and then you can find out. So you have 2 options from here. Let me show you both the options. Yes, the first thing that we are going to assume is this is 1 is to 1 is to 1. So AP is equals to PQ is equals to QB. All are equal. First we are going to solve for this, that is AP is to PB, and which is equals to 1 is to 2. Okay, so we have to apply the, this is M, and this complete here, that is N. So you know that x1 comma y1, x2 comma y2, you just have to apply the section formula. Okay, so how do we write it? For P, the coordinates of P, that is xp comma yp, can be calculated as M value is 1, so that is 1 into x1, that is minus 3, plus n into x1, which is minus 1, divided by 1 plus 2, that is total 3. Okay, so that is about the x coordinate, and y coordinate I can write it as, there's no space here. Okay, so comma, y coordinate is m into minus 2, which is y2, plus n into y1, which is 4, divided by again 3. So let us simplify this. The coordinates of P will be, this is minus 3 minus 2, so that is minus 5 divided by 3. So that is the x coordinate here. Minus 2 plus 6. So that is, this is minus 2 plus 8. Okay, so that will be 6 by 3, and that is equals to 2. So yeah, these are the coordinates of point P. Now I have the coordinates of point P, that is minus 5 by 3 comma 2. And I have to find the coordinates of point Q, which lies in the middle of this line segment PB. So I have a choice. I can apply the midpoint formula here to calculate the coordinates of Q. Okay, so let me do that. And if you calculate, if you apply the same formula here, see, this is 1 is to 1, and the coordinates of P we have just calculated, that is minus 5 by 3 comma 2. Okay, so let me apply the midpoint formula. What is the midpoint formula here? Average of x coordinates comma average of y coordinates. So these are the x coordinates. Let me take the average here, minus 5 by 3, plus of minus, so that is again minus, divided by 2, that will be the x coordinate. Okay, comma average of y coordinates, so that is again 2 plus of minus, that is divided by 2. So this will be 0. Okay, definitely this will be 0. That means the y coordinate of this Q point, that will be 0. And what will be this value? Minus 5 minus 9. So that is minus 14 divided by 1 by 2. Okay, so that will be equals to minus 14. Let me write here, minus 14 by 3 into this 2 by 1 becomes 1 by 2, correct? And this will cancel this 7 times, so it will be giving me minus 7 by 3. Yeah, so these are the coordinates of point Q. Okay, so we have used the midpoint formula method to find the coordinates of point Q. You can use the this as, if you take this ratio, that is AQ, if you are taking this AQ is to QB, that is also fine. You can take a cube, that is 2 parts, and qb, that is 2 is to 1. And you can follow the same procedure here, like this, the section formula. You'll get the same answer. But this one is easier to find. Okay, that's why I told you this one. I hope this is clear. Moving on to the next question, which is a trigonometry question. Okay, so let's see here. We have secant cube of theta divided by secant square minus 1 plus cosec cube theta divided by cosec square theta minus 1, and we have to prove the RHS. Okay, so let me take the LHS here. That is equals to secant cube of theta divided by secant square theta minus 1 plus cosec cube of theta divided by cosec square theta minus 1. Okay, now we are familiar with the identities. I know that 1 plus tan square theta is equals to secant square theta, correct? Therefore, secant square theta minus 1 will be equals to tangent square theta, right? Similarly, I know that 1 plus cot square theta is equals to cosecant square theta, and therefore cosecant square theta minus 1 will be equals to cot square theta. Okay, now I'm going to use these two here and put the value here. Okay, so let's see. This is equals to tan square theta and this is equals to cot square theta. Let's put the value here. Okay, and what we are going to get here is secant cube theta divided by tan square of theta plus cosecant cube theta divided by cot square theta. Okay, now let us simplify this. I know that secant is nothing but 1 divided by cos cube of theta. This tan square theta is nothing but sine square theta. See, the tan theta is equals to sine theta by cos theta, and cot theta is equals to the opposite because these two are reciprocal of each other, so that is cos theta by sine theta. The same identities I am going to use here. This tan square theta in the denominator, that will be sine by cos. If I take the reciprocal, that will be cos square theta divided by sine square theta. The similar thing will happen here also. So 1 cosec cube theta is what? 1 by sine cube theta, because again they are the reciprocal. And if you take the reciprocal of this, in multiplication I'll have sine square theta divided by cos square theta. Now let us simplify this. This will cancel this and we'll be left with 1 divided by sine square theta into cos theta plus 1 divided by, this will be cancelling this and we'll be left with sine theta into cos square theta. Okay, now clearly we can see that what is common here? Sine theta cos theta is common. Okay, so let's continue here. 1 divided by sine theta cos theta is common. What is left here is 1 by sine theta plus what is left in the second term, that is 1 by cos theta. Okay, now 1 by sine theta is cosec theta, 1 by cos theta is secant of theta, 1 by sine theta is again cosecant of theta plus 1 by cos theta is secant of theta. Okay, so is this our RHS? Yes, you can see it from here. That is our RHS. So this is how you solve this question. I hope this is clear. Very simple, easy question from trigonometry chapter. Moving on to the next question, which is the OR part of this 28th question. This is even easier than the previous one. We just have to put the value. P value is this, Q value is this, and you have to prove that this expression will result in the value of P square. So let's put the value here. P square. P is squared here, so that will become secant square of alpha divided by cosec square of beta, that is P square, minus Q is this value, so that will become tan square alpha divided by cosec square of beta multiplied by secant square alpha. So this is my LHS. Let us simplify this. The LCM is same because we have the same term in the denominator. Now that will become secant square alpha minus tan square alpha multiplied with secant square alpha again. Okay. Now What is this expression? I know that 1 plus tan square alpha is secant square of alpha. This is my trigonometric identity. That for secant square alpha minus tan square alpha will be 1. So this will become 1 here. Let me put the value. So this value becomes 1. 1 divided by cosec square of beta into secant square alpha. This is what we are left with. So we are having secant square of alpha divided by cosec square of beta, which can be written as secant alpha divided by cosec beta whole square. And this is nothing but the p-value. So this is what we wanted to prove, and hence we have proved this is equals to RHS. Okay, so in this video we have solved till 28th B part. All right, so stay tuned for the upcoming videos. You can like, share and subscribe the channel and turn on the notifications. Okay, and that will be all for this one. Please let me know in the comment section if you want any question to be solved. Okay, and ask your doubts in the comment section. Thank you.